Hello.
Yeah, Ronald.
Good afternoon, Samir sir.
Yeah. Good afternoon, Ronald. Am I audible?
Yes, you are audible. Am I audible?
Yeah.
Okay.
Am I audible to you all?
Yeah, Garima. Yeah.
Thank you, sir. Okay. Someone has said well, the blockchain symbolizes a shift in power from the centers to the edges of the network. With this quote, I, Kanishka Ganango, on behalf of Acropolis Institute of Technology and Research, wish you all a pleasant good morning and extend our warmest welcome to the esteemed speaker, Mr. Sameer Jain. Our dignitaries, Dr. Kamal Kumar Sethi, HOD, CSE Department, Professor Priyanka Jangre, Professor Nareen Pal Singh Rathod, Professor Ronak Jain, and to all the professor and my friends present here. I officially welcome you all to immerse into the world of blockchain. To begin with, let me give you first a brief introduction to ACM student chapter, which is working to make this event a success. ACM, which is the Association for Computing Machinery, is the world's largest educational and scientific computing society. It delivers resources that advance computing as a science and a profession. ACM Student Chapter organizes various workshops, seminars, and talks related to the latest improvement in the computing society to provide unique networking opportunities, mentoring, and bonding sessions over shared interests. Before getting started, let me give you about a brief introduction about blockchain. Blockchain, invented by Satoshi Nakamoto, is decentralized, distributed, and public digital ledger that is used to record transactions across many computers so that the record cannot be altered retroactively without the alteration of all subsequent blocks. It is a distributed database that maintains a continuously growing list of ordered records called blocks. These blocks are linked using cryptography. Each block contains a cryptographic hash of the previous block, a timestamp, and transaction data. The primary benefit of blockchain is as a database for recording transactions, but its benefits extends far beyond those of a traditional database. Most notably, it removes the possibility of tampering by a malicious actor. Blockchain technology is revolutionizing the way in which world's legal and economic systems operate. It's taking the world by storm. So, to learn more about it, we have an inspiring speaker amongst us, Mr. Sameer Jain. He's a PhD scholar at PDPM, IIT DM Jabalpur in computer science and engineering. He started his research at the institute in 2018 and is working on biomedical engineering. His areas of research interest include image processing, machine learning, deep learning, and blockchain technology. Prior to his current research studies, he worked as an assistant professor at Gyan Ganga Group of Institutions, Jabalpur. He has been assisting Professor Aprajita Oja in a course on blockchain technology and applications for the past 3 years and has developed expertise in permissionless and enterprise level blockchain application development. We are glad to have you, sir. I request you to continue the session and enlighten us all.
Okay, so thank you so much, Kanishka. And I think you have given a good introduction about blockchain technology. So I think we can have a detailed discussion on that. So in this session, so I welcome each and everyone who is present over here. And let's start something with blockchain. More or less, I'll cover things which are very important if we talk about the students learning, and we'll not talk about the more on expertise matters. So we'll take more sessions later on if needed. So this today, because this is the very first session that I'm taking of yours in blockchain, so we'll cover brief things, brief about whatsoever is important. So yeah, so let us start with the session. Let me share my slides. So I'm sharing my window. Yeah. Mm. So is my screen shared right now?
No, sir, no. Your screen is not shared.
Now?
Yes, now it is shared.
Okay. Yeah. Thank you. Thank you so much. So this is the screen. So is it visible now? Ronak, Kanishka, is it visible?
Yes, yes, it is
Yeah.
visible.
Okay. So let's start with the blockchain technology, the today's session. So first, uh, just think about the scenario. Most of you, I mean, everyone have gone through this scenario where you want to send some money from your account to somebody's account. So you are sending money to your friends or a family member. So what you do? First, you log into your internet banking account. Okay, then you'll transfer money. The validation is performed by the bank at both the sides. Like if you have given a correct account number and if you are having sufficient balance in your account, and then there is some updation done at both the parties. So if you are sending some money, so what will happen? The money is deducted from the account from your account, and then it is credited to the the receiver's account. So this whole process needs a central authority. So bank will be a central authority who will be responsible for this transaction and who will validate this transaction. And there are two parties, like who is the sender and who is the receiver. So these three are the stakeholders right now. So there is always a risk associated with these type of transactions. So what is the risk? So risk is that suppose the bank is not working. Like suppose the bank is a fraudulent node. Okay. So suppose he or that bank gives you a denial of service. So what will happen? Your money will be stuck in between. First thing. Second thing is that suppose uh, uh, there is a central ledger that is maintained in the bank, and suppose whatever transaction has been done is not recorded at the bank. So your money is deducted and it is not reflecting at the bank side. So these are the two basic risks that are important. Okay. And the third thing is tampering of the transaction. Like suppose you have sent, say, suppose 1,000 rupees to your friend. So instead of that, somebody tampers that information, and instead of sending 500, 1,000 to the your friend or your some family member, he or she takes 500 rupees from that, and only 500 is transferred. So there is a lot of risk that is associated with these kind of transactions. So blockchain came into existence by looking at these kind of the cons, what we said about the central ledger. So in today's scenario, the banking systems are having a centralized ledger. What is ledger actually? So ledger keeps the records of the transaction. Okay. So whatever transaction is being done, it is recorded in the ledger, and the ledger is responsible for all the information between the client, between these clients. Okay, so it is a book of record keeping. Okay, and all the financial transactions of an organizations are put into the ledger. So, in a centralized ledger, there is a central authority, and that central authority has to be trusted by the transacting parties. Okay, so if there are two parties, then that the authority is the bank is has the authority, and both the parties has to rely on the bank. Okay. However, if you'll see at the right side, This is the distributed ledger. So in the distributed ledger, the need of the third party is omitted. So there is no third party in the distributed ledger. So there are two kinds of ledger: centralized and the distributed ledger. So the cons of the centralized ledger is that suppose the bank takes control over with transactions, and suppose the transactions are posted on the ledger, and uh, suppose bank takes the authority of all these transactions. It obviously takes, and it is not it is a malicious node, suppose. So there comes an intruder, and which is there is a phishing attack sort of thing. So if you are relying on that bank, and some person who is acting like a bank, and you are giving authority to that person, and you are not knowing that. So there is the problem associated with this centralized ledger. So that, because both the parties are relying on that particular entity, so there will always be a problem, because if that is a malicious node, then it can cause a serious damage. Okay. And also, suppose a centralized ledger is maintained by the central authority, and that authority has got shut down. So no transactions will be processed in between. So there is also a latency kind of thing, delay kind of thing. In the, as you have seen during the counseling, like if you have taken the admission through DTMP counseling, that is by the government of MP. So you have seen that sometimes the server is down, so nobody is able to put the choice of the colleges. There is no choice filling kind of thing that is running. So because there is only one central authority that is relying on that server. Okay. So in the distributed ledger, so there is no central administrator. Okay. And there is no centralized data storage. Okay. So it is essentially an asset. It contains, it is a database that contains asset that can be shared across the network. Uh, this is the network. There are certain nodes in this network. So this distributed ledger is shared by every node. Okay. And every node has the same copy of that ledger. So if there is something that is changed to the ledger, then every node in that ecosystem will have a same copy of that ledger. So the, if there is some change, then all the copies has to be changed with that particular thing. So any changes to the ledger are reflected in all the copies. And this is a very good thing when we talk about that, uh, uh, because there was a central authority in the centralized ledger. So if that authority is a malicious node, then the transaction can be, they might have hold in a hold state. But here there is no such kind of thing. So only two nodes who want to communicate with each other, they will communicate, and the whole ledger is, updated. So so the two parties are able to make an exchange without the uh, intermediation of the third party. Okay. So what is the pros? What are the advantages of using the distributed ledger? Is users are in control of the information. What are the transactions that are going on this particular network? So users are um, in that, they know each and everything. So data is complete, that is consistent also. So complete, I mean that because every transaction has to be put into the record, so in the ledger. So data is complete, consistent, and it is obviously accurate, because every node in this particular distributed ledger system has to see that whether the transaction is correct or not. So it is validated, transaction is validated, all of them will validate. Instead of in case of centralized ledger, where only central authority have the permission to update the ledger. So this is also good in case of distributed ledger. And uh, this is the thing that blockchain take into it. That is the decentralized network. So blockchain does not have a central point of failure. When we talk about blockchain, there is no central point failure, and it can the blockchain can resist malicious attacks. So this is what distributed ledger is known for, and the blockchains are always relying on this kind of technology. So this is what I've already told you. Now the blockchain technology. So what is blockchain? So it is an blockchain contains certain nodes. Nodes are actually computers that are connected to each other. So and there is a shared immutable ledger. Immutable is a very important thing that when we'll talk about blockchain, it should be, it should always be in your tongue. Like the ledger is immutable. That is, if there is certain kind of transaction, if it is recorded, it cannot be deleted. So if you need to delete that transaction in the blockchain, it is next to impossible to delete the transaction. So a blockchain in blockchain, this is very important. So it has an advanced database mechanism that allows transparent information sharing. So why it is transparent? Because every node in that blockchain has the same copy of ledger, and he or she or that node can read. It can access that ledger anytime, and whatever is inside the ledger is one and the same for all. So there is no difference in the entries of that ledger. A blockchain can store data in the blocks that are linked to each other. So this is the thing in the blockchain. In the blockchain assets, so when we talk, there are many blockchain networks like Bitcoin blockchain network, Ethereum is there, and Litecoin is there. Many blockchain networks are there. So when we'll talk about asset, so certain blockchain networks talk about, yeah, smart contracts kind of a thing. So suppose in Bitcoin the asset is the coin. So I am transferring that coin to from me to another person. An asset can also be transferred in case of blockchain. So we can create a blockchain network where we can transfer an asset. That asset can be tangible, like we can touch that asset. That can be, in a hard form, like a house, a car, or laptop, or desktop computers, anything. So a land here. So what is intangible assets? So intangible assets are there that are in the form of a paper, or something like that. So the property, patents, and all that. So if you are transferring that assets from one person to another, so this can also be done in the case of blockchain. And we can say that virtually any thing that has a value can be tracked. So the tangible assets also have some value, like a house or car has some value. So we can, it can be tracked through the blockchain network, since everything that has been transacted, everything that is exchanged between the two persons, it is being recorded. So there is a it reduces the risk. And again, because blockchain network is a, there are many stakeholders in that blockchain network. So the cost of, that central authority takes the cost from you is very, it is is lower as in blockchain network. So this is the technology, blockchain technology, that we are talking about. So key elements of the blockchain. So we have already discussed about distributed ledgers. These distributed ledgers have immutable records, and the third thing is the smart contract. So we'll later on talk about the smart contract. Okay. So not every blockchain network supports smart contract. They give the functionality of smart contract, but some of them, and Ethereum is the special blockchain network that took this new concept of smart contract. So yes, in the blockchain technology. So we'll later talk about it. So how does a blockchain network works? So everybody has a question that have think about. You have seen many things like the Bitcoin is there. There are certain, people who are mining the Bitcoin. They have the Bitcoin, certain amount, thousands of dollars they are earning. So how this blockchain network works? So suppose there are two persons. Suppose person A is sending some money to B. So transaction is requested by A. So here there is A, the person A who is requesting, who is sending some money, and for that, for to transfer that money, that person A is actually asking for the transaction. Okay. Now, what will happen? So uh, that transaction is requested, and a block that represents the transaction is created. Okay, so a single block can have more than one transactions. Okay, so there is a pool of transactions. So at the same time, many nodes in the network can ask, and this is the very important thing, that the particular person or node that who is actually asking for the transaction has to be in the blockchain network. So this is the node who is asking for the transaction, and there is a pool of transactions. From that pool of transaction, a block is created. So a block can have more than one transactions. Now, what happens? This block is created, and then somebody who is interested in validating that transaction. Okay, so there are two things: verification of transaction and validation of transaction. So verification is done at the earlier stage, when somebody asks for the transaction, so his or her wallet is checked, that whether there is, because everyone one in the network has that immutable ledger. So that ledger has the entry that whether this person A is having money or not. So what is the how much means how much money he or she is having in his or her wallet. So through he or she is actually, you know known by the public and private key. So we don't know any person by their name. We only know them through a encrypted form. So we have some keys associated with each and every node. So here, so suppose node A wants to send some money to node B, money in the form of Bitcoin. So he or she initiates the transaction. Then the transaction is verified by the nodes, and the block is created. Now this block who is created by those miners who want to participate in validation of that transaction. So verification is done, and then they want to validate. What happens? The block is sent to each and every node in the network. Okay, now they start mining. So after the block is created, there is the mempools. We always say them as mempools. There are fresh unconfirmed transactions in that mempools. Unconfirmed means, confirmed means that that block is not added to the blockchain network. So a block is created right now, but it is not added to the blockchain network. So these blocks are archived, and they are not added to the network until they are validated. Once a block is validated, it is it is attached to the blockchain network. Okay, so how they are validated? So they are validated using this consensus algorithm. So blockchain networks have many, each blockchain, there are many consensus algorithms, and each blockchain network accepts, they have only a single consensus algorithms that every node inside the network has to agree on that consensus mechanism. So what is consensus mechanism? So through that consensus mechanism, through that consensus algorithm, every node who is right now validating the transaction has to, apply that algorithm, and there will be a final result that is validated. And according to that result, if some node has received have has done completed that consensus mechanism, then he or she will be awarded with a coin, or in case of Bitcoin, he or she will get reward. So so the nodes that form a block will try to add the block in the blockchain network to make it a permanent block. So the permanent block is made by consensus mechanism, and the miner I meant that who completes that mechanism. So the miner will get the reward, and here the reward, since it is a Bitcoin network, you can see there are Bitcoins over here. So uh, he will get the Bitcoin. So not a single Bitcoin, but the partial, like some amount of Bitcoin from that, and then block which whose consensus mechanism, consensus has been done, and that block has been validated, then it is added to the blockchain network. So a blockchain has a chain of blocks, and that blocks are are added to the network based on some consensus mechanism, and when they are added to the network, they are confirmed and the ledger is updated with this entry. And one more thing, you have to keep noting that the 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 block has more than one transactions. Okay, so there is a mempool of transactions, and then they are recorded in the blocks. Okay. Now the transaction is complete. As you can see, that block is added and the transaction is complete. So the person A has given money to person B, and if from that the complete money has not been given to B, so some certain amount of like Bitcoin. Suppose A is sending Bitcoin to B, so A has to add some, you know, value to more value, like more money to that transaction, like for the transaction fees, and that fees will be actually taken by the miner who has validated the transaction. So who is the miner? Miner is the person who has validated the transaction. And how he has validated the transaction? By using a consensus mechanism. What is consensus mechanism? Consensus mechanism has something which is related to cryptographic hash, and there is a cryptographic puzzle that he solves and he'll get reward. And after the consensus is complete, the node receive the fees that in the form of a partial value of that Bitcoin, and then the transaction is complete. So this is all what happens in the Bitcoin blockchain network. So what are the benefits of blockchain network? So blockchain networks have higher trust. And the blockchain networks, because why higher trust is there? Because there is a, you know, distributed ledger. So everyone has the record of distributed ledger. Second thing is that, and everyone in that network is responsible. Okay, so this is the thing. And second thing is it has better security. So why it has better security? Because since there are many blocks in the blockchain network, if you suppose I am the malicious node and I want to change, I am the hacker, or I am attacking the blockchain network. So if I want to change some value inside a block, inside that transaction, so I have to change each and every block, because every block is connected with the cryptographic hash. We'll see it later on it. So there is a good security in the blockchain network. Also, there is a cryptography associated in the blockchain, so everyone's identity is hidden, and not directly you can go to that person. So there is, you have to the all the information is encrypted using the public and private keys. So, and this is known as public key cryptography, and there are digital signatures. So everything is encrypted, so they are not readable. And third thing is it has a greater efficiency, so transactions are very quick, and there is no central authority. So there is no possibility of getting your systems down, like the network is down. So if there sometimes it happens that Visa or Mastercard, we are using you know, a debit or in a credit card, and there is a, you know, facilitator who is giving you the power to transact, to transfer money from one account to another account. So these are, you know, intermediaries, or these are gateways which are always responsible for transferring money from one account to another account. So if their servers are down, then there is a possibility that you'll not be able to transact. So in blockchain network, it is not so, because every node is running the blockchain network. Now there is a transparency in the blockchain because the ledger is shared. Okay. Now, so where blockchain can be exploited? So it can be exploited in finance. It can be exploited in healthcare sectors. Right now, I am doing some research there where we are having some kind of medical records, and we are doing something related to blockchain. And we are creating a system that will help the patients, the hospitals, the doctors, all the you know, stakeholders in the medicine, so healthcare industry. So they'll get a benefit with the blockchain. So we have you can also plan for that. Like, you can think of a place where you can apply this blockchain network, blockchain technology, these concepts, and you can create your own product. Now, it can also be applied in the insurance sector. It can be applied in e-governance, like you are having in our Madhya Pradesh. There is MP online portal, so where we can help the government to to for the tangible and non-tangible assets. So, like in the land sort of things, like in the hospitals and all that. So, e-governance in the corporation everywhere. So you can take these projects and you can deploy them. So in media and advertisement, it can be applied in manufacturing. There is the chain, supply chain management. You can apply this in manufacturing. So in elections also, like voting systems are there. So where you cannot change the vote of a person. If I have voted to a party A, then if somebody is the intruder who comes in inside that you know that system, and then he or she changes whom I have voted and changes from A to B. So there is no possibility when you are applying the blockchain. So there are ample fields where we can apply these blockchains. So yeah, it is a very good future when you are if you are planning for becoming a blockchain developer. Now, how blockchain looks like. So blockchain network is a infrastructure where there is a that provides ledger and smart contracts. So we'll talk about smart contract later, but here because we are giving an overall definition of blockchain. So when we talk about Bitcoin, there is no smart contract, but when we will talk about Ethereum, there are smart contracts. Now, here in the blockchain, there are peer-to-peer peers in the computer network. So these are the peers. You can see that each of them are connected with each other. So there is a mesh of these peers who are connected to each other. And there is a here you can see that where nodes collectively adhere to a consensus algorithm. So they have to admit that consensus algorithm. They have to agree with that consensus protocol. So there is a consensus protocol, and for the new transaction it has to be validated with the consensus. So these nodes are connected with each other and they have the copy of this blockchain. Okay, so there is a database sort of thing in every node, and that keeps record of the blockchain. So blockchain is nothing but a record you are having. Now, so the blockchain data structure. So this part I've taken from this book, Mastering Bitcoin by Andreas Antonopoulos. So the blockchain data structure is an ordered backlinked list of block of transactions. So what is backlinked? Okay, so I'll tell you. So in a suppose there are two blocks A and B. So the block A is connected to block B such that the block B has the cryptographic hash of block A. So B has the hash of block A. Suppose you just think about a linked list in the data structures where we are adding a new node at the front of the network, front at the top of that list. Okay, so at the front, whenever you add the thing, so it will have the uh, every node that is added has the address of the last node. Okay, the the immediate node next to it. So in the case of blockchain data structure, instead of addresses we are using cryptographic hash. So cryptographic hash will let you connect from one block to another, and that cryptographic hash is unique for each and every block. So there is no there is nothing like collision where you are having two cryptographic hashes, that single cryptographic hash that can be same for two blocks. So this is something that makes a blockchain. So there is a chain of blocks such that the blocks are connected with each other using a cryptographic hash. Now, the blockchain can be stored as a flat file. So there is a file, and inside that file there is a these this information is stored, like this data structure is stored in that file. So in this form, you'll have a blockchain. Like in coin in this Bitcoin, there is a Google's level DB database. We have Hyperledger Fabric, where there can be more than one database you can use. It is up to you. It is up to your choice that which kind of database you are using. Okay, so if you are creating your own blockchain network, you can have another kind of database you will prefer, but that should be compatible with the consensus. That should be compatible with your logics in that blockchain network. So as I've already told you, the blocks are linked back. Linked back means the new block is linked to the earlier block. Okay. The blockchain is often visualized as a vertical stack. So vertical stack is what is just think about a stack where the first block is at the last and the latest block is at the top. So that is why they are saying like stack. Each block within the blockchain is identified by a hash that I've already told you. So we are using SHA-256 algorithm. So when you'll be in, I think, seventh semester or sixth semester, there'll be a subject that is network cryptography is there, network security and cryptography. So in that you'll learn that what is SHA-256. So there is a digest. What SHA does is, suppose there is a machine where in which you put suppose there is a machine that gives an output of water. So if you will put 10 liters of water, it will give you 1 liter of water. If you will put 500 ml of water, it will again give you 1 liter of water. So SHA-256 always give you an output of 256 bits. Okay, so it is a cryptographic hash. Hash is non-reversible kind of thing. So suppose if you are if there are you have learned about discrete mathematics where we are having inverse functions. So this doesn't have any. This cryptographic hash algorithm has no inverse. Like, you cannot predict from the output that what should be the input. So that is why the attacks in the blockchain are brute force attacks. So we have to check each and every input and we have to compare it with the output. So and that will give you some kind of relation, but there is no reverse relationship. Okay, and each block also references to a previous block that is known as parent block. So in the earlier slide, I have told you that uh, the next block is connected to the previous block, and the previous block will be always called as the parent block. Okay, the very first block that is created in the blockchain network is known as genesis block. Okay, so the genesis block has no parent. So just keep this in your mind that Genesis has no parent, okay? Because this is the very first block. So it is possible in the blockchain network that there is a formation of a block uh, th- uh, with two, like suppose there are two miners. Two miners, they create a block at the very same time, okay, and they want to attach, and they have gone through the consensus mechanism, and the consensus mechanism says okay to that block. But if two blocks are created at the same time, there is a dilemma that which block has to be added in the blockchain. So it creates the forks, blockchain forks. Forks means the blockchain is, it is divided into two, so in or three or whatever. So the fork divides the blockchain network. So although you can think of like uh, if two blocks are created at the same time, they will have the same parent, the last block of the blockchain network, since it is a reverse connection. Like the all the new blocks will be connected with the previous block, since there is only one block previously. So those two blocks will be connected to the previous block. So, multiple children arise due to blockchain fork are temporary situation that occurs when different blocks are discovered almost simultaneously. So, simultaneously they are created. Now, um, uh, blocks that are not there is a way to include a block. So there will be a mechanism. Suppose two blocks are created, so there will be a mechanism to choose any one of them. So one will be chosen, the other will be the orphan block that is not selected in the inclusion. So like I'm not including a particular B block, I'm including A. Both A and B are created simultaneously. So I'll take B block and I'll make A as orphan. Okay, so only one block is selected, and this there will be only single parent for that. So um, this all you already know. Yeah. So how we'll manage these forks? So using the longest chain rule. So longest chain rule says that the new block will be added, it will be dependent on the longest chain, like who is having the maximum number of parents. Okay, so longest chain up. Now, what is longest chain? You'll not be able to right now think about that how it is going to happen. So I'll tell you visually in the coming slides. So the chain of blocks that nodes adapt in the blockchain is the longest chain. Okay, so longest chain of blocks is the chain that took most effort. Most effort means since it is a longest chain, so every block has a cryptographic hash, and since each one is having some hash, it means that this was mined, and it was mined, so there was some effort to make it mine. So if you are mining some, if you are adding some block, you need to go through the consensus. That consensus needs some effort to solve that cryptographic hash, to solve that puzzle, and then it needs effort. So here the longest chain is the chain of block that took the most effort to build that chain. And how to measure the longest chain? Using we can use chain work mechanism to find the longest chain. So chain work is the total number of hashes that are expected to have been necessary to produce the current chain. So whatever is the current chain. So here you can see that these black blocks are is the chain of the is the longest chain. So the connections between these black blocks is forming the longest chain. So here the red blocks are actually orphan blocks. They are not included in the blockchain network. So pictographically, I'll tell you that how this works. So this longest chain rule is applied when two blocks are mined at the same time. So here is the scenario. This scenario says that there is only one block that is mined. Okay, no problem. So it is added to the blockchain network, and all the nodes in the network are updated, and they are having the same chain. So here you can see all of them are having same chain. Okay. Now come to this scenario where there are two block, orange block and green block. Both of them are actually mined at the same time. Okay. So here you can see that two miners find different blocks simultaneously, green block and the orange block. Now both of them validate that block, like nodes in the both of them are validated by the nodes in the network. So they will put, suppose they suppose there are miners, so some miner will take will be interested in orange block, some of the miners will be interested in the green block. So here just understand the situation. Suppose there is a, you know, there is a fest at your institute, and there is a fete or fest at your institute, and you just went to there for some you are going to play some exciting games over there. So some of the people will be interested in playing game A, some of them will be interested in playing game B, and both of the games start at the same time. So you have to choose either of them, and then strange there'll be a suppose there is a situation that you have to decide whether you have to choose that A or B. So here both the blocks are mined at the same time, but you have to validate which block has to be kept in the blockchain network. Okay. So here, block some of the miners have mined block A for all those transactions, and for B for all those transactions from other miners. So same transactions are there in both the blocks, like orange block and the green block. Now they say that these say that I'll support B block, and they say that I'll support block A. Now what happens? So yeah. So in this situation, since there is another block that has been mined after green block. Okay. So here read it like B. So falsely it is written A over here. So read it like B. So suppose after this thing, like has been joined to this chain, and A has been joined to this chain. What happens? there is another block that supports B. Okay, so here there was a fork. There was a fork. Again, when there was another block B, another block that supports B, so the chain of B is bigger as compared to the chain A. So here, when it is found that a particular chain is longer as compared to the fogged chain, then it is decided to keep the longest chain and to omit the that chain. So A will not be the A will not be added to the main blockchain, but it is actually an orphan block. So we'll consider A as an orphan block, and B, the chain with B will be, you know, the main chain, the main network chain for that chain network. So this is the scenario. Okay. Now, we have already discussed this thing earlier, so I'm going to skip this slide. So type of forks. So this was the earlier situation was when there were two. These are the temporary forks, like because the two blocks were mined at the same time. So this is related to the block formation. Okay. Now, there are forks which are actually dependent on certain rules that are updated in the blockchain network. Since there are consensus mechanisms in the blockchain network, there are some things, there are set of things like I just wanted to change the consensus mechanism. So there are set of rules that can be changed in the blockchain network, but all of the people in that blockchain network has to be known with that particular change. So there are two kinds of forks: hard fork and soft fork. So fork is that splitting of blockchain. Okay. So what is a hard fork and what is a soft fork? So in this image will easily tell you that what is a soft fork and what is hard fork. So in hard fork, suppose a software for Bitcoin is changed. Okay, so there is some upgradation in the Bitcoin network that there is a rule that at least 10 minutes should be spent in mining the block. Okay, so the rule is changed. Suppose I'm changing the rule that it should be 5 minutes. So some of the nodes in the network will agree with the new rule. So they will update their local blockchain software, and there is a set of nodes that do not agree with the new rule. So they'll remain unchanged. So it actually, this is the situation when the blockchain is fogged. So here, non-upgraded, these are yellow nodes are the non-upgraded nodes. They haven't changed the software at their end, and the red nodes believe that the new software is better. So in hard fork, hard fork always gives birth to a new cryptocurrency. It always happens. Okay, since the rule has been changed, the same currency cannot be used. Okay, so it gives birth to the new cryptocurrency. So hard fork are always responsible for the new currencies. Like suppose there is a main network, Bitcoin network. So a Litecoin came into existence. So how Litecoin came into existence? With the help of, with this thing, hard fork. Okay, so we have changed the rules. What is soft fork? Soft fork is that if everyone in the system agrees with the new rule. Okay, so there are nodes. The nodes will try to follow the new. All the nodes will try to follow the new rules. Okay, that are uh, and the nodes that are not following the new rule will remain will not add the block in the blockchain. So this is the soft fork, that new rules are updated by each and every node, and who don't want to upgrade the software, so they will not keep in mining participate they will not participate in mining. Okay, so this is what a soft fork came into existence. So in this soft fork, there is a single blockchain. So there is no splitting of that uh, blockchain network. So in hard fork, there is you just memorize it as hard fork is hard, so you cannot, you have to agree with the fork. So there is a, there will be the fork always. Okay, in soft fork, no, there will not be the splitting of the blockchain network. Now, what does a mining in blockchain mean? So, in Bitcoin, when it came into existence, the puzzles actually, the bitcoins were mined using, by solving the puzzles. Okay, there were machines, there were graphic cards in those machines. There were, you know, in which the cryptographic hash has to be calculated, and then they have, if they reached the consensus mechanism, then they have mined a coin. So what happens is, mining a coin means you are going for a consensus mechanism. You are, I'm, suppose there is a, at your institute there is some kind of hackathon that is going on, and in that hackathon there is a problem that has to be solved. So the persons in, the students who will register for solving that problem will be the miners. Okay, so we'll call them as miners, and those miners will try to solve that puzzle, and the miner who will win that puzzle, who will solve that puzzle, there can be more than one miner, but the person who will, who will be very early in solving that particular puzzle, then he will be awarded at your institute. In case of blockchain, you will be rewarded. So rewarded with the Bitcoin. Okay. So this process is known as mining. So in case here, the new bitcoins are actually mined. Okay, so there will be a mining of a new bitcoin. So whenever miner is there, it will have a new coin for that. So there is, in a blockchain network, uh, uh, it I think it is 21 million. 21 million bitcoins can be mined. So when, I don't know right now how many coins have been mined, but the maximum mined coins will be 21 million. After that, there will be only exchange of these coins. Okay, so you will have to pay the fee. Like if there is a transaction going on between A and B, so A wants to send money to B, then both A and B will give money to the miner, and then miner will get rewarded. So no new Bitcoin in that case after 21 million Bitcoins are, mined. So a miner in the Bitcoin validates the transaction digitally and add it to the blockchain ledger. So whomsoever is the miner, that will add the blockchain, that block to the network. So why miner will do this? Because miner has calculated the blockchain, that hash of that block, and without that hash you cannot add that block to the blockchain network. So it is very important that that particular person has a hash for that block to be added to the blockchain network, but that hash has to follow some rule, like that is actually given by the puzzle. So puzzle has something that it gives you something like, this is what I want and it is needed. So in case of Bitcoin network, there is the number of zeros are there in the puzzles. Like it should be, the new hash should be less than the previous block hash. Okay, so this is what is needed. So it is, the new hash is computed using some nuns and all that. So I will discuss later on. So how this is done? So this is done by solving complex cryptographic hash puzzles to verify blocks of the transaction. Verifying means you are creating the hash value, and then if the block is added to the network, then the ledger is updated. So here is the scenario. So a Alice, here this is the girl whose name is Alice and this boy is Bob. So Alice wants to buy something from Bob using a Bitcoin. Okay. So, we'll convert this problem like in the form of, suppose you are paying fees to your university, or your course fee to the university. So what you will do? You are Alice and the university is Bob. So she uses the private key. So you are having you will always have, when you will register for any blockchain network, if you will register for any Bitcoin wallet, you'll have a pair of keys, public and private key. Okay, so this is given by some central authority who is managing these keys all over the world. So they'll give you, so you'll have a public and private key. So she uses her private key and signs a message with the amount of Bitcoin and Bob's address. Okay, so Bob's address is what where Alice wants to send some money. Now the transaction is requested by Alice. Who requests the transaction? Alice requests the transaction. Okay, so you request the transaction for paying the fees to the institute or your university. Now this particular block, that is not a complete block. Okay, this block is not, complete yet, because it has having some information but not the complete information, and the last information that the block needs is the cryptographic, final cryptographic hash. So the network, the nodes in the network will try to solve the puzzle for the Bitcoin network. Solving the puzzle means they have recorded the transaction, but solving the puzzle means the next hash value should be lesser than the earlier block. So the first miner who validates, who is having the hash value that is lower than the previous thing, which is containing the information, that hash is actually coming from the information that is stored in the block. So block has some information, and that information is hashed. A value is created. That hash value is a 256-bit integer. So 256-bit value is there, and then that 256-bit value should be less than the previous block value. So this is what suppose is there. Or there can be a cryptographic puzzle that says that there should be at least 5 zeros preceding the cryptographic hash. So there should be at least 5 zeros, or whatever is the rule that is set to the network by the network. So the miner who completes this thing, and he will be the winner. He will get the reward. Here you can see that Bitcoin is awarded to that miner, and then that miner will add the block to the blockchain network. So then this 3 Bitcoins will be given to the Bob. Now here you can see that after 21 million bitcoins are mined, so there'll be, like, suppose Alice want to send 3 to the Bob, 3 Bitcoins, then he or she has to add some more Bitcoins to give to the miner, because no new coins can be mined. Okay, so this is the thing, and that is why there are new blockchain networks that are coming into existence. So yes, there is a possibility that same network uh, will be there for, for whole hundreds of years, like. So there is a possibility where you will lose your money, suppose that network collapses. So what happens, so today people use this Bitcoin, and unless and until it remains, it is existing. So people are, you know they are actually working on these kind of problems, that how to make a Bitcoin network that is not a vulnerable network in case of the money is exhausted. So Ethereum came into existence where there is no limit in the network. So yes, we are having more networks that has no limit. So we'll go later on. Now the components of the blockchain network. So following other components of the blockchain network, Node, you already know. Node is a system that has some computation power, that can do a consensus mechanism, that can compute a cryptographic hash, that can solve a puzzle. So that is a node. Ledger, you already know that records transactions. Blocks, you already know, there are blocks in the blockchain network that has some certain transactions, and those transactions they'll have a cryptographic hash, and then again cryptographic hash is calculated all over the block. We'll see later on. There's a wallet associated with each of these. Like in this case, both Alice and Bob will be having a wallet. So Alice will send money through her wallet, and Bob will receive money on his wallet. So there's wallet nonce and hash. These are the two most important things that will support the consensus. Consensus is the soul of blockchain network. Without consensus, there is no reliability in the network, and there is no, there is consensus is the only thing that is supporting the blockchain network. So consensus is very important. You have to understand each and every step in the consensus of the blockchain network on which you are spending money, on which you are developing, or the platform on which you are developing your blockchain network. So to support that consensus, nonce and hash are totally that are highly important. So if you'll think about an atom, so the nucleus atom is a blockchain network, then the nucleus is actually the consensus mechanism. Okay, so this is the block. So here, these are the blocks that are added to each other. So this is the latest block. Okay, this is the latest block, and this block is actually connected to the previous block, and this block is connected to the previous block. Since this is block 0, so here a block 0 is having previous hash as zeros. So this field is 0 for the genesis block. So this red field, I've marked it with a red rectangle. So it shows that if it is a genesis block, it should be zeros. Now, there is a hash that is computed during mining. So this hash was computed earlier. So there is a timestamp at which this block was created. So the ledger contains these information about the blocks. So blocks is actually nothing that they are not tangible. They're not. They're nothing but certain values that has to be recorded in a notepad file. Suppose you are having a blockchain network and you are having data structure as a notepad file, so you can keep records of these things. And there are certain kind of databases these days, like structured database, unstructured database. There are XML files, so you can create your own database in a blockchain network using these XML files. So there is ample lot of opportunities where you can launch your product in the blockchain. Okay, so everything you want to change, you can change in the blockchain network. So on the blockchain has is a concept on which you can develop your own network. So here in the blockchain network, there is one thing that is very important, that is a Merkle tree. So what is Merkle tree? So here, I'll explain you. So here in this picture, there are four data one, data two, data three, and data four. So these data are, suppose these are transactions. So suppose Alice want to send some money to the Bob. Now Samir want to send money to particular Anaya, and here Prashant wants to send money to Sunil. So at the same time, these transactions are open. Now there is a mempool where there will be a list of transactions. So some miner, um, uh, some person, some node in that blockchain network who will try to mine for that mine the Bitcoin. Then they will record these transactions in the block, and they will try to solve the puzzle. Okay, so these transactions are first hashed with the SHA-256 algorithm. Okay, so it is secured hash algorithm. Hashing is, I've already told you, this is a digest form. Like if whatever information you'll give it to you, it will only give you 256 bit value. Okay, so it is a SHA-256 algorithm that is used by the Bitcoin. Okay, so here you'll get a hash with this thing, and that. Now we'll take the two hash, because we want a single hash for all the transactions. What we'll do, we'll again perform hash, again perform the hash, again perform the hash, and until we'll get the single hash, and that single hash will be called as a Merkle tree root. Okay, so Merkle root is there. So in each and every block, there is a Merkle root. Okay, so Merkle root is actually, it is composed of the transactions. Okay. Now the nonce. Nonce is very important thing. You will definitely, you have to understand these values. So in Bitcoin blockchain, I'm talking about only Bitcoin right now. So in Bitcoin blockchain, nonce is a value that is added to the front of the block. Okay, so nonce value, when you'll start hashing, so nonce you will add at the front of the block and then compute the hash of whole information. Okay, so what miner has to do? A miner has to try and guess the current nonce. Okay, so that nonce value is dependent on what? The target, the puzzle. Actually, it is dependent on the puzzle. The puzzle, if you want to solve that puzzle needs something in the value has to be in the form of something that is required by the puzzle. So, in suppose puzzle demands that there should be five zeros in the hash value. So, in front of that hash, so you will add nonce to the final hash that is created over here. So, there is a hash. It is created with the Merkle tree root, and then you will have nonce hash value, timestamp hash value. So, timestamp has a fixed hash value. Merkle tree has a fixed hash value. Now with the nonce, you will change. You are changing the hash of this header, sorry, this block, and then that particular hash that is coming out should actually, should solve that puzzle. So here, a miner has to try and guess the correct nonce. Okay, and whatever will come out, that will be called as a target hash. So a target hash is a numeric value that a hashed block header must be less than or equal to in order to form a new block. So this condition is the puzzle. This is the okay. So puzzle is not like whatever you read you have read in your earlier school days or like that puzzle. So this is the puzzle in the case of Bitcoin. So there is a certain condition that has to be met with a new hash, and then that hash value maintains that particular thing, then your block is ready to be in the blockchain network. Unless there is a fork, and if there is fork, then you have to uh, follow the longest chain rule, and then if there are two blocks, then that longest chain rule will be applied, and then there will be an orphan block, and then the main block. Okay. So in Bitcoin, the data is collected in hash on which a nonce value is added and test the difficulty level is met. Difficulty level is actually the hash puzzle. In Ethereum, the nonce is a different thing. Okay, so the in Ethereum nonce is the number of transactions sent from a given address. So the person who has sent more transactions will have very difficulty level of that network. So in case of Bitcoin, the difficulty is using that puzzles. In this, the difficulty is as per the so there is a version 4 piece block, Merkle tree type bits, and nonce is nonce actually added implemented with one and then tested. The hash is computed is really the what puzzle wants from you. So nonce, suppose I am putting one as a nonce value. Nonce is nothing number at once. So it keeps on changing. So suppose I've taken one as the nonce. If it is not working, I'll take two. I'll keep on incrementing with value one, and so on. So in this way, we are actually performing things. So we come to the types of blockchain networks. So there are many, as I have already told you, that the blockchain, the consensus mechanism in the blockchain network is totally dependent on why that blockchain is into existence, what kind of problem it is solving. So there can many kind of blockchain. So broadly classified, we are classifying these blockchain networks into four: public blockchain, private blockchain, hybrid blockchain, and consortium blockchain network. So public blockchain is the blockchain network like Bitcoin, wherever there is a money related thing. So you can directly open your wallet and then try to spend money in that blockchain network. So you're earning money and spending money in the blockchain network. You are transferring money. So these are public blockchain networks. So Bitcoin, Ethereum, Bitcoin Cash, Litecoin, Monero, IOTA. These are the public blockchain networks. there are private blockchain networks. So the private blockchain networks are those networks are limited to the organization. Suppose IBM is designing a block network for your organization, for like Acropolis institutions. So a blockchain network that is being designed for a Acropolis group of institutions, and nobody who is outside that particular organization can use that blockchain network. So this is what a private blockchain network is actually into existence. How? So this is the thing. In these days, many companies have tried to make private blockchain network. Have tried to implement the private blockchain network. They have given the contract to the people who are running, who are able to create the blockchain network for them, and this is how a number of blockchain networks that came into existence. So as they are, so there can be same network, same kind of network within the two organizations, but that will never be communicating with each other. Okay. Now consortium is the consortium like where it is controlled by a group of people, like not an organization but a group of organizations. Like blockchain, suppose there is an hyper fabric. Suppose, yeah, there is a very good example. Suppose we are having an e-governance system where more than one government is trying to maintain a blockchain network. So suppose the government of MP handshakes with the government of UP, handshakes the government of Rashtra. So these three governments are trying to build a blockchain network that are communicating with each other. So this is will be known as consortium blockchain network. Now, since Bitcoin and Ethereum are two most popular blockchain networks, so I just don't want to miss this thing. So the creators of Bitcoin was Satoshi Nakamoto. He's actually don't know who the person is. Nobody knows in this. So he's anonymous person who has written a white paper on this Bitcoin network, and he published that network. And Vitalik Buterin was the person who has actually created the Ethereum network. He has a team for more people like Hoskinson, Gabe, and Jeffrey. So these were the people who were there in his team. So the Bitcoin is the oldest network, and it has the highest market share when you come to the public blockchain network. So it was launched in January 2009. It was, and the Ethereum was launched in 2018. Currency is this platform. So it has, fiat currencies. Traditional fiat currencies means rupee is the fiat currency. It's traditional currency. So these are known as fiat currencies. So to it is Satoshi Nakamoto make an alternative to these fiat currencies, and this Ethereum has both the things. Like it has currency in the form of ether, as well as it gives you a platform for creating smart contracts and applications. So, and there are apps like MetaMask is there, Truffle is there, Ganache is there, many things there. So, in case of Ethereum, there are many things, but in case of Bitcoin, is the only thing that you have to, you have to do something with the finance. Now, both these till now, Ethereum and blockchain, both of them work on proof of work, but now it is proceeding towards, it is changing protocol towards proof of a stake. So there is kind of thing. And now time. 10 minutes in every 10 minutes a block is created in case of Bitcoin network, whereas in Ethereum 15 seconds. So here there is a thing that you have to think upon. 10 minutes on an average, 10 years back, whatever there, they were having low power, and they were taking 10 minutes. Okay, nowadays the systems are powerful enough, so they should not take 10 minutes, but they are taking 10 minutes. So while creating the blocking, Satoshi Nakamoto, what he think of, since the systems in the coming generations will be of having a high computing power, be equipped with the graphic cards, good processors, with more number of cores, more hash, and all that. So the puzzles the consensus mechanism that we, with the that should be made harder. So if you compare the puzzle 10 years back, what was the puzzle, and right now what is the puzzle, the harder or difficulty level has increased a lot. Okay, that is why in today's scenario machines are taking 10 minutes. Okay, so these puzzles are very hard. Now transaction throughput is 7 transactions per second. Here there are 30 transactions per second, because on an average the block time is lower in case of Ethereum, so there are no transactions. Supply here, what I was talking earlier, that supply is 21 million bitcoins. Okay, so there will be only 21 million bitcoins in a net. They will be exhausted. So after they have been exhausted, then they'll be exchanged. Okay, so no new. Suppose actually Satoshi Nakamoto about gold. So he created the Bitcoin when he paired Bitcoin with the gold. So there is a limit that in Earth we can mine the gold, and after all gold, mined in the earth, there will be only the exchange of gold in the countries for that transaction. So this is what he think of. And in case of Ethereum, there will be an infinite supply Ethereum. So we'll move to the next thing. Consensus mechanism in block. Okay, there are hell lot of consensus mechanism in blockchain that validates the, and because of the consensus mechanism, the transaction is considered to be completely secured and kind of. So we'll see that there are these 8 or 10 consensus mechanisms. Taken this from this medium.com. So the proof of work consensus mechanism is followed by Bitcoin, Dogecoin, Litecoin, Ethereum proof of work. Okay, so Ethereum has two. Right now they are having two chains like Ethereum and Ethereum proof of work. Okay, or we think of Ethereum proof of work and Ethereum POS proof of. Okay, so Ethereum is Ethereum proof of stake. This is Ethereum proof of work. Then Cardano, Solana, Ton, Coin, Ample. Like if you will think of, there are hundreds of blockchain networks that are running right now. Graphene is there, from which is delegated proof of stake. So what is a stake here? Stake here is how much value you are putting into transaction. You like suppose if I'm gambling sort of things somewhere, so I will put stake into the game. Like I'll put this amount of money, like $1,000 for the particular thing, this game, and if I'll if I won that game, then if I win that game, I'll get that amount of money plus certain incentives. This is what proof of stake is there. So the more money you have, the more Ethereum you have a more, you will given more attention. You'll have more credibility in blockchain network. So Ethereum supports this. Okay, so this a sort of capitalism thinking. So, and there are many blockchain consensus mechanisms. So proof of work versus proof of stake. So here uh, there is mining. Case of Bitcoin, there is mining. So in proof of work, we are mining something using some calculation, by solving some kind of puzzle, using some computation. In proof of stake, the creator of a new block is chosen in a deterministic way. Okay, so you need to solve that particular thing, but there is a then a certain kind of steps you have to follow, and then you will find that the person who is having more wealth will be given more priority. Okay, so a reward given in case of proof of stake, a reward is given to the person who solves the block. Okay, the proof of stake system, there is no block reward, so there is no reward. So minus actually what happens in case of this example where Alice was sending money to the Bob. In that case, in case of Ethereum, Alice wants to send money to Bob, then Alice have to pay the fees in the form of gas. when we are talking about Ethereum blockchain networks. Ethereum is the thing that is, that is the value, and it is actually a currency, cryptocurrency. But what is gas is the fees, transaction fees, and that gas can be converted by Ethereum. Okay, and here in the proof of work, network miners come to be the first. So they need, and like they will try to solve that puzzle as early as possible. In proof of stake, several thousand times it is most cost effective, because in case of proof of work, the miners who will lose that thing, but suppose they were not able to mine the thing, they lost all the computation power that was used to mine that particular block, that sorry, that crypto. So here they have lost that computation time, have lost that computation power at that time. But in the proof of stake, since it is deterministic, then there's no losing kind of thing. Now we come to the Ethereum part. So what is Ethereum? So Ethereum is again, because it is a blockchain, so it is a decentralized open blockchain with smart contracts. So it is having smart contracts. In Ethereum, there are decentralized apps. Okay, so we will call it as D apps. Okay. So in D apps, you can exchange some money in the form of gas. Okay. And Ethereum has its own currency that is known as Ether. And next to the Bitcoin, Ethereum is the most popular, and it is having a good market value. So what are smart contracts? So um, uh, we'll try to make a smart contracts later. So smart contracts are generally written in some certain language, Solidity or JavaScript or something. So these contracts have some conditions that should be met, and after when they are met, there is something that has to be achieved. Like in databases, you have triggers. So in triggers, like suppose I'm doing something like uh, I'm triggering that whosoever has a birthday on that particular date, this message has to be sent. So that trigger is set that if the day is matched with date of that particular person, then there is to be a birthday match that has to be sent to that person. So in this way, you can create a smart contract. And a smart contract is what the two people agree with on some conditions. So there is some agreement between the person while signing the smart contract. Not only two, there can be more steps in a smart contract. So they are usually used to automate the execution of agreement, and we'll see later on. So Solidity is the language in which we can create the smart contracts for the Ethereum virtual machine. So in its network, we can, if you want to create a smart contract, we can use Solidity as a programming language. It is a high level programming language. It is object oriented, and here they are saying that it is a contract oriented language. So in case object oriented language, we write class A, and then we put braces and all that. In C++, we used to use keyword class. In case Solitary, we in case place of class, we'll use the contract keyword. Now, it is designed to run on Ethereum virtual machine. So yes, Solidity runs on EVM, and there are many libraries that are supported by that. So it is very similar to Java. So if you know Java, then it will be very easy for you to switch over the Solidity language. So you can be a blockchain developer. So we will be using this remix right now to create a smart contract. Okay. So if time permits me, can I create a smart contract? Uh, uh, can you allow me a smart contract if time permits? So are you there, Ronak? Somebody there?
Yes, sir.
So uh,
Yes,
how
sir.
much time is left, so that I have to
We
manage?
can conclude only, sir, if possible.
Okay, okay. So
We can move for
let
question and
yeah, yeah. So let us see. I'll take questions at my mail ID. I'll share it with the students. So let me tell them one more thing, that is Rex ID. Okay. So it will take hardly 1 2 minutes. So
okay,
students,
no,
yeah, students, you can type Rex ID in Google, and then you will go to this page where there is a Remix project. So here uh, there are two options, that either you can use online ID option or the desktop option. So I'll move to the online option, because we need not install this Remix in local machine. So let us because there is no time, so we'll go for this greeting.sol file. This is greeting.sol file that is written. I think it is visible to you all. So let me. So this is the Solidity version that we are using in this program. So here we are doing nothing but for Acropolis I have made this program. Yeah. So here what we are creating a contract, smart contract, that is the name of this contract is Acro. So there's a constructor, and there's a local variable for this particular contract, that is name, and this constructor initializes this name, and we are having two functions, get name and set name. So deploy this smart contract on a blockchain network. This Ream ID will give you a virtual smart contract, virtual EV, this Ethereum blockchain network. So here since you have if the program is written, you can do this Solidity compiler, and here you can see that there is this arrow kind of thing shows that you can take versions that are greater than 0.5.0. So these are the versions. There are right now the latest version is 0.86.7, and we are running this in 0.5.0. So we'll take any version that is greater than 0.5.0. So we'll take 0.65. Now what you have to do is to compile that smart contract. So here compilation is done. So there are many things like IPFS. I don't have much time to tell you about many things that has needed to discuss in case of blockchain. So you can publish smart contract to any like IPFS interpretary file system in the Swan and all that. But here the remedy will give you a blockchain network. So the virtual machine for this is London. Then lane provider, injected web provider are there. So MetaMask wallet, and there is another blockchain network that is running in your machine using Ganache. So there are many things. So here in this blockchain network there are 10 machines. Okay, so each node is having 100 ETH. So suppose I am deploying this on the first node. So this deployment here this is done. So what we have done, we have taken the environment, we have taken account, and now we are deploying. So deployment says that this constructor needs to create an object, but this constructor needs some name form of string. So I'm giving my name here, and then I'm going to deploy. After deployment, you can see here. Uh, yes, after deployment, you can read it. Yeah, there is some transaction hash that has been computed, and the gas amount that it has taken is to 28 2,10,918. Okay, so this is some transaction cost. You know that Ethereum will not allow you to mine this Ethereum value, but there is a cost. Okay, and there is an execution cost. So this once this contract is deployed, so you will have an instance of that contract that is here, and here suppose I have to get the name. So okay, so the name I'm again giving you. That name is right now it is some. If I'm giving you another name, Anura, then we'll do this thing. So get name and set name, nothing has been performed, nothing is going to be performed. So there is no transaction values, no green sign over here. Okay, for set name has no green sign because it is not going to sign anything. But name, a transaction has to be recorded, and if it is recorded, then that needs gas value. So set name, get name is Anura, set name is now it is Anura. So that earlier we asked Samir, but now if we are getting the name as Anura, then it is. So this is how we can create contracts. We can create contracts like we can do some voting. I have created contract for voting. So this is voting.sol, and there are many things you can do. So this is the contract. There are a hell lot of lines. You have to read each and everything. We can do some kind of mechanism. So that's all from my side. Ronak, thank you for giving me this opportunity to share my knowledge regarding this blockchain network. So thank you, Ronak. Thank you, everyone.
Thank you, sir.
Thank you so much for this informative session. Now, anyone having any questions regarding the blockchain technology, then our speaker.
So I'll leave my email ID with Mr. Ronak, and if there are questions that are need to be asked by the people who are not able to think right now, they can write it to me.
Good afternoon.
Yeah, yeah, Harsh. Yeah.
Sir, as a second student, what are the mini projects I can make?
Okay. So many projects that you can build in that you go through the smart contracts platform like in the Ethereum machine. So you can like suppose you want to transfer some asset from one place to another. Suppose if there is a shop kind of thing, like shop is there. Okay, or there is a you know uh, the any kind of shop is there, like medicinal or daily needs shop is there. So you can design a virtual environment like Flipkart and online shopping sites are there, and for each and every product you can design a wallet for a single person. He or she will transact that money with wallet and contact. So this can be a scenario. Second thing, fee payment system you can build up, you know, counseling sort of thing, counseling small platform you are creating to allow seat from your institute to a particular person. You can even try to make a blockchain network such that the certificates you are providing to the students that should be encrypted with the blockchain. Nobody will be able to tamper those certificates. A digital can be created with the blockchain network. So these are very small projects that can be done by using the smart contract. Okay, so yeah, or you can deploy Geth. Geth is there. A tool is there for Ethereum platform. So you can go to Geth also. Geth. So you can, or one more thing is IPFS. You can go through the IPFS. IPF will help you in store records in the blockchain network. And one thing, there are many things. So one more thing is Hyperledger Fabric. So in the Hyperledger Fabric, if you want to create mini projects, so there is a good, you know, I'll tell you. There are good tutorials that are available in the Hyperledger Fabric. So here you can like you can have a private data you need not to share to somebody. You have couched examples, you have asset transfer examples. So there are many examples that are in this tutorial section under this page. So using these examples, you create your own. So in this way, you can do it.
Thank you, sir.
Good afternoon to all present here. It is such an honor to get the opportunity to thank all the dignitaries on behalf of the ACM Student Chapter and ACM Women Chapter. I, Kanishka Kanungo, would like to express my gratitude to all the esteemed delegates of the webinar for their presence and contribution to make this a great success. I extend my heartfelt gratitude to the speaker of the session, Mr. Sameer Jain, for gracing the event with its presence. Thank you, sir, for inspiring and encouraging us with your words. A special thanks to respected Dr. Kamal Kumar Sethi, Head of Department Computer Science, AITR, for providing immense support to make the event a successful one. I would like to extend my gratitude to Professor Priyanka Jha, Faculty Advisor of AITR ACM Women's Cell, Professor Narendra Singh Rathor, and Professor Ronak and AITR ACM faculty advisors to systemize the webinar on such a trending and ambitious subject. Also, hearty thanks to the team of AITR ACM Women's Student Chapter for organizing the event, and a special thanks to all the participants to make this webinar successful with active participation. Thank you, everyone.
Thank you so much, Sameer sir.
Thank you so much, Ronak, for giving me the opportunity. Yeah, thank you.
Thank you so much. So now we are ending this
Yeah.
meeting and event.
Yeah.
Okay, thank you so much.
Okay.